It is tricky to be able to tune and tweak some features if we don't know they exist. And in this nugget, I'd like to introduce you to socket pools and cache locking, including both what they are and how we can view and tweak their parameters. And I'd also like to do a little bit of review on some commands that we can use to verify DNSSEC, which we implemented in our previous nugget. Let's begin by taking a close look at a DNS request made by our server out to an internet server. So here we have a packet that's coming from the source address of our server, DCNUG, going to an internet DNS server ending in .10, and it's a standard query looking for www.google.com. So in this row right here, it's showing us the source and destination IP addresses, and in this row right here that's highlighted, it's showing us the layer 4 protocol, which is UDP, and also the ports in use. So in this example, the source port was 61,306, and the destination port is 53. And that's the well-known port that DNS servers are listening on. So the question may come up, how in the world did this DNS server choose 61,306 as a source port? And the answer is, it spun a wheel and it just grabbed some random high-numbered port and used it for this connection. And by default, Windows Server 2016 has 2,500 ports that it could choose from for a source port when it is initiating a DNS request. And that's just for IPv4. It also has another 2,500 by default that it can use for IPv6 DNS requests, which is probably enough. However, if you want to increase that amount, you can specify the maximum number of source ports in the pool to choose from. Could be up to 10,000 as far as the range. And you can also set up exclusions if you don't want to use certain ports or certain ranges of ports. You can set those up as well. And when we start tinkering with or controlling the quantity or the range of ports to pull from, we are actually modifying the DNS socket pool, making the pool larger or excluding ranges from that pool and so forth. Now, when the response comes back from this query, and here as we take a look at packet 163, the packet capture Wireshark is showing us that the response is in 164. So if we click on 164 to look at the details of that, we have the response coming back from that source port of 53 on the server side, coming back to our local port of 61,306. And if we expand the answer here down below, it's also got associated with that record a time to live. So what that means to the local server is it's going to cache this in its DNS cache, and it's going to start a countdown. And when 300 seconds goes by and that countdown goes down to 0, it can then be flushed from the cache. And I've got a question for you. What if before that time to live expires and before it's removed from the cache, we get new information regarding www.google.com? Maybe it's a different A record, and they could both be valid. There's more than just one A record associated with www.google.com. Or it could be maliciously done. Maybe there's a malicious attacker who's trying to poison our DNS cache with the intent of directing our clients to the wrong IP address. Well, here's the deal with cache locking. By default, cache locking is set to 100% on your DNS server, which means that once we've learned that record and it's in the cache, we are not going to update it or believe changes or anything else regarding that record until the timer expires, until the TTL goes to 0. At which point, if we need that information again, we can query it, or if we get that information again, we can update the cache with that new information, and we can start the time to live clock again. So cache locking is a feature that's on by default. And if we want to modify that, we could. We could say, well, you know what? We don't want to wait the full 100% before we'll believe an update. Let's go ahead and go to 50%. So that way, when the TTL goes down to half, meaning we're halfway through the lifetime for that cache record, if we get new information and we've set the cache locking to 50%, it'll go ahead and update the cache. And caching in general is one reason why when a DNS record gets changed somewhere, it may take hours or days for that information to propagate everywhere else. So let me walk you through how we can both view and change the properties for the DNS socket pool as well as the DNS cache locking. So in our hands-on lab environment, I've logged on to our Windows 10 client machine. I've opened up PowerShell. I did a Control-Shift-R as we've done previously to go ahead and open up a PowerShell tab to DC-NUG. And on DC-NUG, if we wanted to look at, for example, the DNS server cache information, we could use the command get-DNS server cache. In this case, I'm going to highlight that line and press F8 to execute it. And among other things, what that command shows us is that the locking percent for cache locking is currently set to 100%, meaning that if the TTL hasn't expired, we are not going to bother updating our cache if we receive updated information about that record from other DNS servers. If we want to change that, we can use the set DNS server cache command -locking% and then the percentage we want to set it to. In this case, let's set it to 90. So with that command highlighted, we'll press F8 to execute that. Then we'll go back to the get command and we'll do an F8 on that just to verify that the changes took. So we changed it to 90. In the output, it now shows that the cache locking is set for 90% of the TTL. Let me go ahead and squeegee that off. Next, let's take a look at verifying what our socket pool size is. By default, it's 2500 for each of our protocol stacks, one for IPv4, one for IPv6. And if we want to see the size, we're going to use the DNSCMD command, /info socket pool size. And with that selected, we'll press F8 to execute that. So here it's currently showing that in decimal, it is 2500, which is 9C4 in hexadecimal. If we wanted to change that, we would use the DNSCMD command again, but this time with the /config /socket pool size and the size we want to set. And the maximum number is 10,000. So with that command highlighted, we'll go ahead and press F8 to execute that. And then we'll go back to our info on socket pool size and launch that again just to verify that the changes took. So this command set it, and this command verifies what it's now set to. Also, in our previous nugget, we did DNSSEC, and I had a couple of additional commands that I was playing with and looking at, and I wanted to share them with you as well. So since we're right here, let's go ahead and take just a few moments to review a couple of commands that could be useful in the verification of our DNSSEC that we set up in our last nugget. And one of the commands regarding DNSSEC is get-DNS server DNSSEC zone setting. We're going to specify -zone name and then the zone name we want to check on. And that's a quick way to just get a bird's eye view of the DNSSEC zone settings for that zone. There's also commands for getting the DNS server trust point, which is row 2 right here, get-DNS server trust point -namespace and our name of nuggetlab.com. If we execute that, it's showing us our trust point name of nuggetlab.com, which is also in that DNS interface in the GUI. And if we want to see the anchors that are in that trust point, we can use the command get-DNS server trust anchor -name nuggetlab.com. And if we execute that, here we have the trust anchor data, which includes the protocols used and the keys. Also, from a client perspective, if we had set up policy for a name resolution policy table, which we did, to say, hey, go ahead and do DNS requests with DNSSEC for nuggetlab.com, if we wanted to see that on a client, what we could do is go to that client. So we're going to go to tab 1 and issue the command get-DNS client NRPT policy. And that would show us what policy we have in place. And we could use that to confirm that we have a policy telling us to use DNSSEC for a specific domain. So here the namespace is nuggetlab.com and DNSSEC validation required is set to true. We could also use resolution-based commands with PowerShell, like resolve-DNS name, the name we want to resolve, and with the -DNSSEC OK option at the tail end. Let me go ahead and squeegee the output below, and let's run that command with an F8. And that's another way to verify that DNSSEC is functional for this record. So there's the fully qualified domain name, there's the query type, and the RRSIG represents that we've got a digital signature associated with that record. It also has the signer information and the signature information down below as well. And also, if we go back to DNS Manager in the graphical user interface, and we go to our forward lookup zones, after we applied the DNSSEC to our zone, we're also going to have this little lock symbol on the icon for our zone. We're also going to have a whole bunch of additional records, which are used as part of the authentication in DNSSEC. So in this nugget, we did 3 basic things. We took a look at how to both view and change socket pools as well as cache locking, along with what those features do. We also took a look at some additional commands that we can use to verify our DNSSEC implementation we did in our previous nugget. And I would encourage you to go ahead and launch the hands-on lab and walk through these same commands that we did together in this video to help reinforce the skills and the learning that you've done. So have some fun with the hands-on labs. I hope this has been informative for you, and I'd like to thank you for viewing.